Hello everyone. In this video clip today, I'm gonna show you a brief review of something called graph transformation. It will be, or maybe a little bit different from what you've seen already in college algebra, and I claim it's gonna be a little bit more generalized, and it's gonna help you to move on to the next course better. You have the same rules apply to both variable x and y, and maybe even z later on if you study Calc 3. Okay, so basically what you have is a graph. Say for example, y equal to 3x squared minus 4x plus 1. By the way, this graph is a function. Okay, this is a function. This equation is a function, and the graph is a parabola. That's what I meant. Okay. And you guys are going to learn how to shift the graph, which is a parabola right here, up, down, left, right, or even flip it over the x-axis, flip over the y-axis, stress or compress horizontally, or stress or compress vertically. The only thing that I will not be talking in this section is how to rotate this graph. In order to rotate a graph, you guys are going to learn two things. Number one is matrix. Number two is angle. And then you multiply by a matrix of sine, cosine, theta, and then you're going to rotate the graph as well. But we just briefly cover move up, down, left, right, flipping over, or compress, or stretch, okay? And I claim that the method I'm showing you right here works for any kind of equation. No need to be a function. You may have something like this. 3x squared minus 2xy, so just make it up, plus x squared minus 2x plus 1 equals 0. That's another one. This I think is a conics. Okay? And you can use the same method to shift or transform that graph any way you like on the xy coordinate. Okay? And the idea is going to carry to three-dimensional space. You have one more variable of z, and the method is going to be the same. So let's start with this one. Okay? First of all, or maybe both. We'll talk about move up or down. Say go up 5 units. Whenever you want to move something up and down, you are changing the y value. So if you want to move up 5 units, what you need to do is you need to change y to y minus 5. Okay? That's everything going to move up 5 units. I think let me make a table then. That'd be easier for us to cover all of things, okay? Instead of write one by one. So let me make a table. Easy to say. Okay, make a table. Original equation and then a new equation, right? Original equation said it's y equal to, what was that, 3x squared minus 2x minus 5 or something? Doesn't matter. Okay, try another one. I'm just giving another example, just coming out of my mind randomly. 2y squared minus 3xy plus 7x squared minus 2x plus 1 equals 0. Okay, so if I want to move up, say 5 units. You are moving up means that you are changing the y values. Okay? This is what you need to change. You need to change y to y minus 5. Then everything will be up 5 units. You have a new equation representing a new graph that is 5 units above the original one. This is my original one. What we're trying to say here is this. Whenever you see a letter y, you guys are going to change it into y minus 5. This is what you got. Y minus 5. See, I see a y change to y minus 5 equal to 3x squared minus 2x minus 5. And I claim that this new equation represents a new graph that is 5 units above the original graph and looks exactly the same as the original graph. Okay? And this is originally what you should have. However, I claim that most of the time college algebra people tend not to write this way. Instead, what we do after is supposed to be this step first. All right? And after this, we're going to simplify. Add 5 on both sides. So what you see is this. Y is equal to plus 5 here. Okay? Plus 5 here. This is what? 3x squared minus 2x minus 5. And then you add 5 until the end. The equation, and you can move up 5 units. There's nothing wrong with that. It's just omitting the important step of really what it is in here. Because I claim since not all the time you can add 5 on both sides and simplify. And this example right here, say it all. Okay. So this is a conics. Okay. Here's another graph, and then if you want to shift the whole graph, could be whatever it is. Okay. Move up 5 units, change y to y minus 5. You will have this. Whenever I see a y, it becomes y minus 5. So it's 2 times y minus 5 squared minus 3 times x times y minus 5. You see what happened in here? Minus 3x, okay, minus 3x, y becomes y minus 5, and plus 7x squared minus 7x plus 1 equal to 0. I keep everything else the same, to change y to y minus 5. Similarly, you want to go down, instead of subtracting, you do adding. Now things gonna be shifted down, whatever units you want. Okay, so stay down 3 units. You need to change y to y plus 3. Okay, and then rewrite it. Y plus 3 equal to this. 2 times, let me just write down. Y plus 3 equal to 3x squared minus 2x minus 5. This one from the original one right here becomes 2 times y plus 3 squared minus 3x. Y plus 3 plus 7x squared minus 7x plus 1 equal to 0. Now clever. This new equation right here represents the graph that is exactly what it plus y plus 3, yeah. Represent the graph exactly 3 units below the original graph and looks exactly the same as the original graph. Alright, so you see it's up and down here. So the reason why I give you the bonus video clips about this section, because I want you to think of shift it up as changing y to y minus 5 instead of adding 5 to the end of the equation, like what you see most of the time in your college algebra. Okay? Because we are working with an equation in general. It may not be a function anymore. And I claim that, see, this one right here, there's no way for you to add 5 on both sides and simplify, or I'm going to make a mistake, right? Or subtract 3 on both sides and then simplify the y. It won't work. Okay? Now, you guys are going to see the similarity in here. What if I want to shift left and right? Up and down, you're changing the y value. Left and right, now you got to work with the x coordinates. Okay? So you say you go to the right about 4 units. By similarity, you know what to do, right? I'm going to change x to what? X minus 4. See? Move up to the arrow direction. Y to y subtract something. So move right. Just change x subtract something. And of course the same idea in here. My original equation right here. So my new equation gonna be this. Y equal to 3 times x minus 4 squared minus 2 times x minus 4 and then minus 5. Okay? You see what happened from the original equation? I change x to x minus 4 for every single x that I see in the equation. All right? And of course, if you have time and if necessary, go ahead and simplify the amount of line terms. You will have a more compact answer. But this is the idea. Okay? Of course, similar in this more general example right here, you can change x to x minus 4. You will have a new graph. This is 2y squared minus 3 times x minus 4 times y plus 7 times x minus 4 squared minus 2 times x minus 4 and plus 1 equal to 0. Are we good? Okay. And now, again, by similarity, what if I want to move left? So let me cheat a little right here so I don't have to rewrite everything. Say move left, 4 units. So change x to x plus 4. Plus 4, plus 4 for x. Plus 4, plus 4, plus 4. The whole graph will be shifted up 4 units. Okay? In here, in the example, I'll give you the whole number like 4. You can shift up like 1.725 units. That's okay too, the same idea. All right. So, for shifting up, down, or left, right, you subtract or add a number into the x, the y or the x value. More precise, you change the variable, the y or the x variable, into a new variable, x minus something or y minus something. You're going to change. Okay. Now, what if I want to flip over? I'm going to call reflection. I'm going to flip over the x-axis of the y-axis. What do we need to do to flip the graph over the axis? Okay. Let me draw the first graph. I don't know the second graph, but let me draw the first one. Say the graph is going to be somehow like this. Okay. And if you flip over the x-axis, you're going to have somehow like this. Okay. Flip over the y-axis, you have something like right there. Okay, so how do we do that? Start for reflecting over the x-axis. Okay. How about flipping it? Flipping over x-axis. So what do? Is you flip something over the x-axis. Say, imagine this is my x-axis. I have a point above the x-axis. I flip over. It's gonna be below the x-axis, right? What do we change now? What are we changing in here? We change y to negative y. Okay? You change y to negative y. And that will give you a new graph, new equation, of course, new graph, upside down from the original one. So whenever I see a letter y, I'll change to negative y. Equal to 3x squared minus 2x minus 5. And again, back in college algebra, at least in our textbook that we learned before, people try not to write this way. They try not to write negative y. So what do? They multiply or divide both sides by negative 1, and this is what you see. And this is the version that you haven't seen in college algebra. Negative 3x squared minus 2x minus 5. Okay, and I claim there's nothing wrong with it, but originally I claim this is the previous step of getting to what you've seen in our textbook, college algebra. Okay. Same thing here. Y change to negative y. What I have is 2 times negative y squared minus 3x times negative y plus 7x squared minus 2x plus 1 equal to 0. And of course, go ahead and simplify if possible. You have the new equation that is upside down compared to the original equation. And similarly, what if you want to flip over the y-axis? Okay, flipping over the y-axis. By similarity, you know what to do. What you need to change is you change x to negative x. See? This is my y-axis, right? X. Flip over becomes negative x. Alright, so my new equation is going to be this. Y equal to 3 times negative x squared minus 2 times negative x minus 5. And of course, you do the same thing for the other example. I keep y the same, 2y squared minus 3 negative x, y plus 7 negative x squared minus 2 times negative x plus 1 equal to 0. You guys see the way I wrote? Change x to negative x, I put negative in parentheses. Everything else I copy the same. It's very important because in here, if you simplify, negative x squared, it's just x squared. But this one is what? Negative 2 times negative x, you're going to have positive 2x, okay? And I'll leave the simplification part for you guys to practice. Good? I bet up to now, so far, you guys get the idea of how to deform a graph of an equation in general, but in here I haven't changed the shape yet. It's still the exact same shape, it's just moving around or flip over the x and y axis. Now let me deform the graph a little. Let me stretch vertically by a factor of, say, 3. And what it means by that, whenever you have a point on the graph, say this point right here, right? If I stretch vertically by a factor of 3, it means what? It's going to be 3 times further from the x-axis. Right? Originally, this is how far it is from the x-axis. You stretch that point by a factor of 3, means what? It's going to be 3 times taller than the original point. In other words, if you are 6 feet tall, stretched by a factor of 3, you become 18 feet tall. Okay. And of course, same thing for the point that is below the x-axis. You have a point right here. You stretch it by a factor of 3, it's going to be the point that 3 times. This will be right here. 3 times lower. Okay. And what can we do to stretch a point vertically by a factor of 3 or 4 or 5, any numbers? You're going to change, of course, the y value again. And this is how we're going to change. Stretch vertically by a factor, say, of 3. What you need to do is you change y to y over 3. Okay. See, we move up, we subtract, right? Change y to y, subtract something. We move to the right, we change x to x, subtract something. Okay. We stretch vertically, we change y to y divided by something. And of course, whenever you see, the rule is what? Whenever you see a letter y, you're going to change to y over 3. Everything else keep the same. You're going to have a new graph that looks 3 times stretched out from the x-axis compared to the original one. Okay, so the new graph will be this. Y over 3 is equal to 3x squared minus 2x minus 5. Back to college algebra, people try not to write y over 3 in here. Instead, they give you the more simplified version of this. They multiply both sides by 3, and then this is what you're going to see. Y is equal to 3 times 3x squared minus 2x minus 5. And as our in our textbook say what? You want to stretch the graph a factor of 3, you multiply the entire quadratic function by 3. There's nothing wrong with that. It's right. I want you to go one step prior to this step so you see really what it is before you get to here. Okay? And the same thing in there. Y becomes y over 3, so I got 2 times y over 3 squared minus 3 times x, y over 3 plus 7x squared minus 2x plus 1 equal to 0. Whenever I see a letter y, I change to y over 3. And I got a new graph that is stretched out by a factor of 3 vertically. Okay? And by similarity, what if I don't want to stretch? Instead, I want to compress vertically. Compress. I want to squeeze the graph vertically by a factor of 3. And then instead of dividing, we need to multiply by 3. Okay? Now the new graph is going to be this. 3y is equal to this, right? And again, our college algebra textbook, all right, this way, divide both sides by 3. So 1/3, 3x squared minus 2x minus 5. Okay? Same thing here. Instead of y over 3, we have 3y, 3y. And of course, this new graph is going to look different from the original one. And how different? It is kind of shorter. Okay? How much shorter? 3 times shorter. Okay? Similarly, what if you want to stretch or compress the graph horizontally? This time, you don't change the y coordinates anymore. instead, you guys are going to change the x coordinate. All right, so compress horizontally by a factor of 3. So let's change the factor. How about by a factor of 5? Okay, you compress horizontally by a factor of 5 means what? You're gonna make the graph 5 times thinner, and you're gonna change x to compress, multiply. Okay, kind of opposite of what you think, right? You move up instead of adding, right? Think of subtracting, should be right. And then move to the right, subtract from the x, move down, you add from the y, right? You stretch vertically, you divide, right? Compress, you multiply. Same thing for x. Now you got what? Y is equal to 3 times 5x squared minus 2 times 5x, and then minus 5. Same thing here. 2y squared minus 3 times 5x, y plus 7 times 5x squared minus 2 times 5x, and plus 1 equal to 0. Okay? And last one, instead of compressing, what if you want to stretch? Now I bet I don't need to talk much. You know what to do. Change x to x over 5, 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 and x over 5. Okay. So in this section, so far I've just showed you how to deform a graph step by step, and you can apply the deformation or transformation one step after another. You can change. Say for example, you have a graph, you can move up. You have what? You do what to move up? You change y to y minus something. Move up, right? And then after moving up, you have a new graph right here. You want to move the new graph to the right. Say 5 units. You change y to y minus 5. I'm sorry, change x to x minus 5. The graph will move to the right 5 units. Okay? And keep going. Doesn't matter how many steps you have. Just each operation is done by one formula right here. You should have to the final answer. Okay. Hopefully this helped for your learning in general. Thank you for watching, and have a good day.